In this video, I'll be going through the question you see on the screen here from the 2023 Leaving Cert Higher Level Maths Paper 2. If you're looking for a different question from this paper, check out the description below. There should be a playlist there. And if you're looking for a different paper entirely, have a look around on my channel. I'll be doing all this on a whiteboard, hopefully like you're used to your teacher doing. But we are on YouTube, so take advantage of the features there. Watch it at half speed or double speed, and certainly pause and try the question first. If you find this video or any of my videos useful, I would greatly appreciate a like or subscribe, but what helps especially is sharing it with a friend that might be doing the Leaving Cert this year or next. In question 9, they tell us all about these shapes. They have a couple of drawings, which I won't try and copy, but about tiling a floor. One has a pattern of all squares and the other has a pattern of all hexagrams. Quite complicated sounding, but the first question simply is extremely simple. It tells you there's a square, its area is 140 centimeters squared. What's the length of one side? So the length of one side is just the square root of 140, which if we get that out to decimal places is 11.8 to the nearest one decimal place, 11.8 centimeters. In part 2, it's not too much more complicated, but they ask us to do the same thing for a hexagon. A hexagon. They tell us it's also 140 centimeters squared, but they help us out. They didn't have to do this, but they tell us it's made up of 6 equilateral triangles, like that. So I'm sure there's a formula, I don't know it, for the area of a regular hexagon. And if you know it, you can just use that, very simple. But I'm going to find the area of one of these triangles. So I'm going to forget this big shape, and I'm just going to find the area of one of these with x on the bottom. Now remember, they told us it's equilateral. So that's x. We can tell you everything about this, 60, 60, 60. I just don't know the length yet. But I know quite a bit about it. So what's the area of one of these? Because I know 6 of them is this. Or to say it another way, divide this by 6. 23.333. So that's the other way. This area of this is equal 23.33 is another way to do it. Or 6 of these is equal 140. Okay, so how do you find the area of a triangle? There's lots of choices here. Honestly, there's lots of choices. They'll all work. There's a formula for when you have 3 sides to a triangle. We could put that into it. We'll get an answer in x, but we know the answer, so we'll solve for x. That's one way. I don't think students would do that. The 2 ways I think students would do, hopefully the easy way you would pick is a side by side, x squared that is, sine 60 is the area of this, and 6 of them is equal 140. Solve for x. That's the easiest way. Let me just do a slightly longer way, because I think a lot of students would end up doing it this way. They would try and get, when lots of students see triangles, they think base by height, so they try and get height. I do this myself a lot. So I'm going to draw a triangle that's half the base, so x over 2, and we're going to look for this height here. There's 2 ways to do this. One way is, if you know this angle 60, you'll find the height, and the height will end up being, I guess, sine 60, pretty much, x sine 60, so you get similar looking here. So I'll do it slightly different, because, again, you would get the same answers here. The other way would be to notice that this side is x, so let's say this side is y. That means x over 2 squared plus y squared is equal to x squared. We try and solve that. That's x squared over 4, and this is just an x squared, so it would be y squared is equal to 3 over 4 x squared. All of these are positives. X and y are both positive numbers, so y is equal to square root of 3 over 2 x, and that means the area here is equal to a half the base, x over 2, times the height, which is square root of 3 over 2 x, which all ends up equaling a half x squared square root of 3 over 4. Actually, the answer came out wrong. Quick edit there I did. The answer came out wrong, and I'm like, what's wrong here? of course, I don't want half of this. This is already half of it. So I need to multiply this all by 2. So we put a 2 there. And that gives us this triangle. Instead of what I found was the area of this one. So the area of this one was 2 more. And we get this, a half x squared square root of 3 over 2. And square root of 3 over 2 is just sine 60. So whatever way we do this, we all keep getting the same answer. We get this, and then 6 times this guy, or let me write here, 6 times this guy, a half x squared square root 3 over 2 is equal 140. Let's see, that goes into that 3 times. Rearrange this, we get x squared is equal 140 times 2, 280, divided by this 3, divided by that square root of 3. Put this into a calculator, square root of this side into a calculator, and we get to 1 decimal place, we get 7.3. In part B, they give us this shape here. Again, they can tile a floor with this, and they give us loads of numbers for this. They haven't filled most out on their drawing, so let me put them in here. They tell us this length is 8, they tell us this angle is alpha in the drawing, and then in the writing they tell us the rest. This length here is 4, and this length here is 6. And for part 1, B part 1, they simply want us to find alpha. They tell us the answer, but they want us to find alpha basically. And let's see if it agrees with theirs. This isn't as hard as it looks. I don't care about this big shape. Alpha and all of these numbers are all in the same triangle. Yeah, my drawing's bad, but other than that, it's 6, it's 4, and it's 8, and there's alpha. We know 3 things about this triangle. We can work out everything, except if you know 3 angles, which that's not the case. So let's see, no right angles, can't use that. Sine rule, we need 2 angles, can't use that. So cosine rule seems the obvious one. If we're going to be using this angle, or finding it, we better use the length across from it as the starting point. So that's 4 squared is equal, the other 2 lengths squared, 8 squared plus 6 squared, just like Pythagoras theorem. What makes it different is we then take away these side lengths, 2 times these side lengths, and multiply by cosine of this angle, alpha. Just rearrange that. We'd end up getting cosine alpha would equal, let me see, I've wrote it out here. This minus these 2 would be minus 84. Then divided by all of this, that'd be minus 96. Is equal, let's see, the 2 minuses cancel. These both cancel down to 7 over 8. And that's what they gave us once we moved the cosine over. Alpha is equal to the inverse cosine of 7 over 8. And that's the answer to part 1. In part 2, they tell us that this angle here is a right angle, and to use that information to find the total area of the entire quadrilateral, the entire thing, A, B, C, D, and all the letters are on their drawing. Okay, so how do we go about that? Oh, I'm sorry, before we go any further, I have the wrong right angle in. The right angle is the entire shape here. So how do we go about that? Let's draw the top half here again. If I draw that top half, I know this side is 8. I know this is a right angle. All I need is one more piece of information about this triangle. And we know alpha. Alpha is right here. To put this in calculator, it's just a number. I'll leave it as alpha until the end. We know 3 things about this. We can find everything we want, including the area of it. Once again, we can get the area by getting this side, and then we have this length by this length times sine of this angle. Or we can get the length of this side and just multiply the 2 and get half of it. So I'll choose to find this guy here. We'll call it x for now. So what is x? It is, we have the opposite of this angle and the adjacent. So we better use something like tangent of alpha is equal to x over 8. So x is simply equal to 8 multiplied by tangent of alpha, and we know what alpha is. It's cosine minus 1, 7 over 8. You can put all that into a calculator. and we get 4.426. I assume that goes on for a while. You make sure to save this. This is not the final number we're looking for. This is just this length here. So the area of this triangle is a half 8 times x, and we're just then looking for two of them because they told us it's symmetrical. So we're just looking for two of those. Just put that in a calculator. This cancels. So 8 multiplied by whatever number's in your calculator here. And that should come out, let's see, 8 times 4 is 32, so somewhere around there. And I get 35.41. In 9 part C, they set up, they give you a really complex looking drawing, but then we don't really actually have to use that. It comes down to this part here. They draw us a circle. They tell us this is a unit circle. They could have left it at that and made sure and hoped we knew what it meant. But they also gave us a formula. X squared plus y squared is equal to 1. A unit just means it's radius 1. And they drew another circle. It's sitting on the x-axis here, and it hits at a point Q over here. And they want us to find this point for Q. They tell us the answer, but they basically want us to find it again. And they do tell us that this information here, this is 45 degrees. Okay, there's a good few ways to do this. The very simplest way is to understand about unit circles and trigonometry. And that is that if this angle here, this angle here is 135. XY is just found by cosine and sine. So that would be it. To find this point here, this point here is just cosine of 135. I hope I haven't mixed these up. Sine of 135. Put them in and you should find what they gave us. Apologies if it's the wrong signs or I have these the wrong way around, because I'm not going to do it this way anyway. Another way to do it would be, what was the other ways I found? There's a few of them. Oh yeah, another way to do it would be to get an equation for this line. And that might sound difficult to do, but it goes through the center. So this line here I'm talking about that hits this point, it goes through the center, so the y-intercept is 0. So we just need to know the slope of this. And the slope of 45 degrees is 1. This is just going negatively. So it's just minus x. That's the equation of this line. We can just put these two guys together and again find the points they told us. 1 over square root 2 pretty much. That's another way to do it. The way I'll actually do it out is I will draw a little triangle in here. And this is pretty much where this comes from, to be honest. But this would probably be the most common way to have done this, or if you didn't know this. If we draw this little triangle, let me draw that out again. What we know about this is that's 40, let me draw that a bit bigger. Plenty of room here, we do. 45 degrees. We just need to find the height of this, because that's the y number. We need to find the length of this. Once we put a minus in later, that'll be the x number. It's just how far from the center it is. And that seems like hard because we only know two things. But remember, we know the radius, it's 1. So that's it, that's all we have to find. The height of this, let's call this one x and this one y, although we'll have to change the x to a minus later. So let's see, sine of 45 is equal y divided by 1. And by the way, this is why we use unit circles. Nothing special about the length 1. It's just really easy to divide things. It just disappears. So y is just sine 45 as and sine 45 should be the same as sine 135. Don't make me check. And then x, by the same thing, this x here is equal to cosine 45. Now cosine 45 doesn't equal cosine 135. There's a minus difference, and that's because we're going to the left there. So the final answer would also be minus cosine 45 and sine 45. These two are the same, and if you put them into a calculator, they both should come out as 1 over square root 2 and 1 over square root 2. Oh, one more thing, sorry. Most calculators actually show this as square root 2 over 2. Same number. Okay, so that's a few ways to show that. Personal favourite is probably this way. Intersection of lines. It does actually work out really neatly because this goes through the centre 0 and this is a unit circle. In part 2, they tell us something that is a known fact, but it's okay if you didn't know it. They tell you that the center of this circle is actually hit by the tangent at these 2 points. So that's actually a known fact, and the same is true for this center. I haven't drawn the circle too well, but the tangent of that guy and the tangent here intersects there. So this is a provable fact, but they gave it to us. So what they're basically saying is the tangent will go through the center, find the center, and also while you're there, find the radius. So I'm simply going to try and find the tangent at this point, and we now know this point. I'm going to try and find the tangent at this point. Bit easier. Well, I'll do this one first. So we have a circle, we have a point that is, let's see, minus 1 over square root 2 and 1 over square root 2. Find the tangent of it. Well, to find the tangent, we actually need the center to get the opposite slope. And the slope to the center, we can find that. Again, we actually already know it's 45 degrees, so it's tan of 45. And also we discussed up here, it's actually tan of 45 is 1, but it's a minus. So it's a minus. Sorry, I said it's tan of 45. It's actually tangent of 135. Or it's minus tan of 45. Anyway, either way, you could also just get 0, 0. Do the slope formula. You'll find 1 over square root 2 divided by minus 1 over square root 2 will give you the slope of minus 1. That's for this line here. So what's the slope of the tangent of it? The perpendicular of it? So the slope of that line is, the slope is 1. I guess I should put in maybe perpendicular here. So the equation of this tangent is y is equal to 1 times x, which is x, plus some number. Don't know it yet, but I do know this point. This point is on this line. So we get 1 over square root of 2 is equal to x is minus 1 over square root of 2 plus some number we don't know, we'll find it out in a moment. Add these together, we get 2 divided by square root of 2 is equal to c, or to write that another way, square root of 2. So the equation again is y is equal to x plus square root of 2. I can nearly squeeze my answer in down here, but let me just rub out this area just to make sure. So this equation is the tangent at this point here. So I still need to find where it hits the center. So I want the equation of this tangent, and I will fit that in over here, because we could do the same thing, the identical thing I did here, find the slopes. Although I guess at one point I'm going to find the slope being infinite, which might give me a little trouble. But yeah, I could do the same thing, and if I knew how to deal with that infinite problem, I'd find the answer. But I can be a bit more common sense about it. This is just a vertical line. Because look, it's a horizontal line to the center. It's just a vertical line. And we know how to write the equation of vertical lines. That vertical line is just x equals whatever number it hits at. And it hits at minus 1. Because that's the radius. So it's just x is minus 1. They're these two tangents. So where did these meet? Again, I will actually just squeeze it in here. When did these two agree? Instead of x we have minus 1 and plus square root of 2. And that's it. That's the x number and the y number. The point, the center of this here is just, what did I say? Minus 1 and minus 1 plus square root of 2. Put that in a calculator, but they asked to keep it in Cert form. Oh sorry, they still want the radius. But again, let me draw it here again. Yeah, let's zoom in on that guy. We have this center point. We know this point. They're right at top of each other. This point is minus 1, 0. This point is minus 1, well, minus 1 plus square root of 2. What's the height difference? It's just this number. It's just this number. The radius is just this number. Minus 1 plus square root of 2. Check it's not a minus number you're giving them. Then you'd have to change it to a positive. But it's not. That's a positive. We're on the positive side of the y-axis, I guess. Yeah, that's the final part. Yeah, that's the final part of question 9. Always hard to teach these big questions I always feel I've not explained things right, because it's hard to explain these long run out questions. If you find some problems, something you need clarification on, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day.